Good evening. In the last lecture, we discussed properties of determinants. Let us revise them. First property, if we interchange all the rows and columns of a determinant, value remains the same. Second, if any two rows or columns are interchanged, value of the determinant changes, but in sign only. Third one, if any two rows or columns of a determinant are identical, value of the determinant is nothing but 0. Next, if all elements of a determinant, in fact, if all elements of any one row or column of a determinant are multiplied by some constant k, value gets multiplied by k. Suppose determinant is of order 3 by 3. If all the 9 elements are multiplied by k, new value is k into k into k, that is k cube times the original value, right? So don't say it is just k times, because all the 9 elements means R1, R2, R3. When we multiply R1 by k, value gets multiplied by k. R2 by k, again k. R3 by k, again by k. So in all, k cube. From this property, again, we can say that if all elements of any one row or column have a common element k, it can be taken out as a factor of determinant. Then, if all elements in any one row or column are expressed as sum of two elements, then determinant can be expressed as sum of two determinants. And the most important property is, if to the elements, listen to me carefully, if to the elements in any row are added the same multiples of corresponding elements of any other row or rows, value remains the same. For example, R1 changes to R1 plus 1 upon 13 R2. This is allowed. But if I say C3 changes to C1 minus C3, wrong, because to the elements in column C3 and not minus C3. Minus C3 means you have multiplied C3 by minus 1. As a result, determinant gets multiplied by minus 1. Also, transformation. These changes are called as transformations. Like R1 changes to R1 square, or R1 changes to R1 into R2, or R1 plus say 7, such transformations are not valid. Exercise 4.2, third sum, second part. Show that determinant 1 log y to the base x, log y to the base, or rather, what is that? Is it correct? Yes, log z to the base x. Second row, log x to the base y, 1, log z to the base y. Then third row, log x to the base z, log y to the base z, 1. Value of this determinant is 0. We have to prove this. Let me tell you that in this property, rather in this sum, change of base property is used. I have not mentioned the base. It can be any valid base. So just see this. Log y to the base x can be written as what? Log y upon log x. Base is not mentioned. It doesn't mean baseless logarithm. It only means base is the same. Log z to the base x is log z upon log x. See this 1. As these two denominators are log x, I replace this 1 by log x upon log x. Is it correct? Yes. Log x gets cancelled. We get 1 only. Second row, base of logarithm here, it is y. So this 1, see the cursor, is written as log y upon log y. Here also change the base, log x upon log y. Ideally, I should have written, suppose base is 10, log x to the base y is log x to the base 10 upon log y to the base 10. I have dropped that base and I have just written this. Similarly, log z to the base y is log z upon, this should be log y. I'll change that. This should be log y. Okay. And what about third row? Log x upon log z, log y upon log z. Now denominator is log z. So I replace this one by log z upon log z. Now I have taken 1 upon log x, 1 upon log y common from R1 and R2. See, how to write this, you can decide. Some students may say, can we write multiply R1 by log x? Yes, but when you say multiplying R1 by log x, you have to write 1 upon log x outside the determinant. So it is as good as taking 1 upon log x common. Okay, so 1 upon log x common from R1, R2 respectively. Now you may ask me, why not to take 1 upon log z common from R3? Yes, it can be, but why? To prove that value of the determinant is 0, it is sufficient to show that any two rows are identical. If you want, you can take, but I have taken only 1 upon log x, 1 upon log y common from R1 and R2 to get this determinant. Don't forget to take to write this outside the determinant, right? Because this is a factor of determinant. Now R1 is R2, so value of the determinant equal to 0. Fourth question, solve the following equations. First one, determinant x plus 2, x plus 6, x minus 1, x plus 6, x minus 1, x plus 2, x minus 1, x plus 2, x plus 6. This is equal to 0. Now, it is not asked that without expanding or using properties, etc. So you can expand as it is, but we'll try to simplify this. For that, I use R2 changes to R2 minus R1, R3 changes to R3 minus R1. You may ask, how can we apply these two at the same time? See, when I say R2 changes to R2 is changed, R1 is not changed. So I can say R3 changes to R3 minus R1, right? So on applying these two, we get this. At this stage also you can expand. But if I use C2 changes to C2 minus C1 and C3 changes to C3 minus C1, I get this determinant. This is equal to 0, right? Now expand this and tell me the value of x. So x plus 2 into what? Minus 110. Don't say plus 1 because this product plus 1 is to be deducted. You have to be very careful while expanding. You will notice that 111 is multiple of 37. So why not to divide by minus 37? To get this, open the brackets to get final answer as minus 7 by 3. We'll do second sum here only. Actually, triangle property can be used. All elements below diagonal are 0. So value is directly product of diagonal elements. When I say diagonal, principal diagonal. So x minus 1 into x minus 2 into x minus 3 is 0. Otherwise, expand as it is. X minus 1 into x minus 2, x minus 3 minus 0, minus x into 0, plus x minus 2 into 0. So it is just product of these three factors equal to 0. So x minus 1 is 0 or x minus 2 equal to 0 or x minus 3 equal to 0. That gives me x equal to 1, 2 or 3. Fifth is for homework. I have given hint. First apply these, then take 2x common from R2, R3. Note that when you say 2x common from R2 and R3, outside the determinant, you have to write 2x into 2x. Don't write just once, write twice because you have taken 2x common from two rows. Then C2 changes to C2 plus C1, C3 changes to C3 plus C1. Answer x equal to 0, x equal to 12. Again, without expanding is not mentioned. So you may expand the determinant as it is. That is also not difficult. Now, this is an important sum. Sum number 6. Without expanding determinant, show that determinant 136, 614, 3712 plus 4 times 233, 212, 176 equal to 10 times 121, 317, 326. See, you have to be very careful. Observe all the three determinants carefully. You will notice that uh, 317 is common. Consider LHS. 317 is common. Now 6412 is there, but here 326 is there. So take 2 common. Let me explain first. Take 2 common from C3 in the first determinant. You get this. Now you will notice that second and third columns are identical. So we can add, not in this step. Why? Because this is 2 times, this is 4 times. So multiply first column by 2. Now you will say, why not to divide again? See, this is a factor of determinant. I'm not using additional 2. I'm using this 2. I can use this 2 for any row or any column. This is perfectly right. Even if we take 2 common from column and give it to row, no problem. Because 2 is a factor of determinant. I can utilize that for any one row, of course, not all, or any one column. So multiply first column by 2 and here first column. Why first column only in both the cases? Because second and third columns are identical. Now this step is important. So add corresponding elements of first column. See, last but one property, I think. If all elements in any one column are expressed as sum of 2 elements, determinant can be expressed as sum of 2 determinants, isn't it? Right? Yes. So 10 can be taken common from 7 to get this. Now, is this the required right hand side? No. We need 133 as first column. So interchange all the rows and columns, value remains the same. So 10 into this. Yes, this is nothing but right hand side. Now, this is second sum. Please listen to me carefully and do write the solution after the lecture. Prove that determinant x plus y, y plus z, z plus x, z plus x, x plus y, y plus z, y plus z, z plus x, x plus y is 2 times x plus y z, rather 2 times x y z, zx y, y zx. Let me explain. See, you should know what is to be obtained. First row is x, y, z. Okay. Now, by R1 changes to safer side, we write R1 arrow, R1 plus R2 plus R3. This is also correct, but many students get confused. So it is better that we write R1 arrow, R1 plus R2 plus R3. So first row becomes 2x plus 2y plus 2z, each element. Now you may say, sir, this can be taken common. Do we require that outside the determinant? No, we want only 2. So take only 2 common from R1. You get this. Now use common sense. In the first row, in the required determinant, we need x, y, z. Here x, here y, here z. This means you have to use R1 minus R3. See, from x plus y plus z, if you subtract y plus z, you get x. From x plus y plus z, if you subtract z plus x, you get y. And from x plus y plus z, if you subtract x plus y, you get z. Yes, this is the required first row. Now to get required second row, we use this. It is better if you say R2 changes to R2 minus R1. So that gives me z, x and y. Yes, these are the required elements. Then R3 minus R2. Z gets cancelled, x gets cancelled, y gets cancelled. What remains is y plus z plus x. Yes. So this is the required answer. Now this is a good one, not from the textbook though. Find by inspection means using properties. You're not supposed to expand. Find by inspection two values of x if value of this determinant equal to 0. Consider this determinant. Take 2 common from R2. Now you will say, but sir, it is not highest common factor. Yes, I know, but still we can take 2 common. I can take 2 crore common also. The only thing is I will have to write 2 crore outside the determinant, and second row will be now 2 upon 2 crore, 3 upon 2 crore, 2 upon 2 crore, like that. Okay, so that is allowed. Now, what is the reason for that? So that first column becomes 1, 1, 1. I hope this is clear to you. When 2 is taken common, to take common means to divide. Divide each of second row elements by 2. So 1, 3 by 2, 1. Now, value of the determinant is 0. So can we take R1 identical with R3? See, I'm not saying yes, we can. We are going to check that possibility. Is 1 equal to 1? Yes. Can 3x be 9? Provided 4x square must be 36. Let us check. 3x equal to 9. So x equal to 3. What is the value of 4x square? Yes, 36. Is that clear? So one of the values must be 3. Now can we equate R2 and R3? Is 1 1? Yes. Can 3x be 3 by 2? In that case, x will be half. But for that value of x, is 4x square 1? Check. 4 into half square, 1 by 4. 4 into 1 by 4, 1. Yes. So by observation, what are the values? Values of x are 3 and half. Now we start with miscellaneous exercise 4a. Actually, first question is on multiple choice questions that we will solve later on. Let us solve sums using properties. Second is actually expand determinant with or along second column. Second column elements means which elements? A12, A22, A32. I have already explained this, that multiply second column elements by their cofactors and add the products. You get value of the determinant. Okay. I think in this case, value comes out to be -2 for the second sum. Now, third one, first part, evaluate this determinant, which you can see on the screen, by using properties. Now, I hope you will be able to solve this. Just take 200 common from R2. Take 200 common from R2. So 200 into 2, 3, 5, 2, 3, 5, 48, 47, 18. So this is 200 into 0 equal to 0. Reason, R1 identical with R2. Just a minute. If you want to say multiply R1 by 200, that is also allowed. But after this step, you should say 1 upon 200. Why? Because when you multiply first row by 200, value is 200 times the original value. When we write equal to, we should not change the value. So 1 upon 200. Why? Because we are multiplying first row by 200. Otherwise, here I have taken 200 common from R2. So it is considered as factor of determinant. You have to mention the reason that value of the determinant is 0 because R1 and R2 are identical. Second, C3 changes to C3 minus C2. So third column is 1, 1, 1. And then C3 changes to C2 minus C1. It is better that we write these two steps separately. You may argue that when we say C3 changes to, we are not changing C2. Yes, but eventually we are going to change C2. So don't mix these two steps. Now by C2 changes to C2 minus C1, you get second column also as 1, 1, 1. As two columns are identical, value of the determinant is nothing but 0. Now fourth is again simple one, find minor and cofactor. Okay. So we'll be solving sum number 5, first part, second part for homework. Uh, so this determinant is 0. Actually, you can directly expand it, but I have used this R1 changes to R1 minus R2. Then I have taken 2 common from C2 and 5 from C3. Actually, we should write that and then expand the determinant. You have to be careful. 0 into something 0, minus 3 into, omit this row and this column. So x square minus minus 1, that is plus 1, plus 5 into x plus 1. So divide by 10 and then open the brackets to get this quadratic equation. 3x square minus 5x minus 2 equal to 0. So what are the factors? X minus 2, 3x plus 1 equal to 0. So x is either 2 or x is minus 1 by 3. Actually, second is for homework. Answer is 2 by 3. Sum number 6. By using properties of determinant, prove that value of the determinant equal to 0. Again, simple one. R1 changes to R1 plus R2. So each element in R1 becomes x plus y plus z. Take x plus y plus z common to get first row 1, 1, 1, second zxy, third row 1, 1, 1. As R1 and R3 are identical, value of the determinant is nothing but 0. Seventh sum, second part. We'll be doing first part in the next lecture. Prove that determinant x a y b z c a square b square c square 1, 1, 1 is equal to determinant x y z a b c b c c a a b. If you observe determinant carefully, both LHS and RHS, you will notice that ABC should be taken common from first column, second column, and third column respectively. I'm not saying they are HCF. See, take a common from first column. So this first column becomes XA. Don't write 1. Each element, when we take a common, should be divided by A. So 1 upon A. Then second column YB, 1 upon B. Third column ZC, 1 upon C. Now, we have taken from columns. Now give that to third row. Why? Because that is required. So I have written by ABC R3. See, we are multiplying third row by ABC. So we should divide determinant by ABC. So this ABC is already there. It gets cancelled. Or you may just say we are using this ABC to multiply R3. So don't write anything. So that gives me which determinant? X, Y, Z, ABC, BC, CA, AB. This is nothing but right hand side. So that's it for today.